Okay, our essential question for today is how can you use exponents to write numbers? Our goals are going to be writing expressions using integer exponents and evaluating expressions involving integer exponents. So for some key vocabulary here, we have our power, and a power is a product of repeated factors. Okay, so what we can see here is that our power is going to be referring to the entire expression over here. Okay, it includes the bottom number, the big number, and the little number, the top number up here in that right hand corner. When we're talking about our base is a power, or the base of a power is the common factor. Okay, it is the common factor. It's that number that we are using to multiply over and over and over again. Okay, so it is this big number, and that is our base. Okay, it is our foundation. It is that factor that we are multiplying over and over again. Then we have our exponent, and our exponent of a power indicates the number of times the base is used as a factor. So that is that little number right here, and that little number tells us the number of times that we're going to be multiplying our base. So since we have a 5 here, that means we have 1/2, and we're going to do it 5 different times. Okay, now down here on the bottom we're looking at prime factorization, and prime factorization is where we're going to be breaking down a number into its component pieces, where we can find out what prime numbers can multiply together to make that original number. So as we look at this number right here, we have 48, and we know that 8 and 6 multiply together to make 48. I know that 4 and 2 multiply together to give us 8. I know that 3 and 2 multiply together to give me 6. And I know 2 and 2 multiply together to give me 4. Now as I look at this, 2 does not have any numbers or whole numbers that multiply together to give it 2, so that means 2 is going to be prime. Or 2 cannot be divided evenly by any whole number other than 2, and it's 2 and 1, which makes it prime. So as we do that, we're trying to get down to all of our prime numbers. So as we look at all of our prime numbers down here, we can say that if we multiply all of these prime numbers together, that we will get 48. So 2 times 2 times 2 times 2 times 3 is going to give us 48. One way that we can rewrite this using our exponents is to notice that we have 4 2's, so we repeated that multiplication 4 times, which means we can write it using a power. So we can put 2 into our base because our base is what's being repeated, and we can write our exponent of 4, and that is because it repeated 4 times. So we can say 48 is equal to 2 to the 4th power times by 3. Okay, so we're going to practice writing some expressions using exponents. So we're going to take each of these products and we're going to rewrite them using exponents. So as we look at this right here, we have -7 times by -7 times by -7. So what I can know is my base is going to be -7. And when I do this, I see that it happens 1, 2, 3 different times, which means my power is to the 3rd power. Now as I look at this, I have pi times by r times by r times by r. So if I do that, I'm going to have pi raised to the 2nd power because I have 2 times that it repeated. And I'm going to times that by r raised to the 3rd power because that repeated 3 times. Now, when we are doing this right here, our negative signs do in fact matter. So since we are multiplying -7 times by -7 times by -7, that means that negative sign needs to come inside this parentheses. Okay. Now, say for instance, I want to go backwards, and I say, okay, I want to take -7 to the 3rd, and I want to write it in repeated multiplication form. It would look like that, okay, where I have -7 times by -7 times by -7. If I left off that parentheses and had that raised to a power, that in fact does not go back and look like this, because this power is only going to the base that's right next to it, which means it's actually not going to be including that negative sign. So what this right here is going to look like as repeated multiplication is going to have this negative sign out front, then a parentheses, and then 7 times by 7 times by 7. Okay, and that's going to make a big difference when we are working with even exponents. because in the case of even exponents with the parentheses, that means our answer is going to be positive, but without the parentheses, our answer should be negative. Okay, so as we are writing these expressions using exponents, we can see that we are using 4 as our base because that is what is being repeated. So we're going to say this is going to be 4. Then we count up how many times that this happens. So that's 1, 2, 3, 4 times. So we can say it's going to be 4 to the 4th power. Then as we come over here, our base for our first one is going to be this -2 because we are using that -2 and we're doing it 2 different times. So that would be to the 2nd power. Then our base for this next piece will be x, so we'll say that it'll be x to the 1, 2, 3rd power. So we can say -2 squared times by x to the 3rd power. So go ahead and try these on your own. Once you have finished with these, go ahead and push play on the video so that you can go ahead and see if your answers match up with mine. So on this first one right here, we can see that we have a base of 1/4. And then we can see that this happens 1, 2, 3, 4, 5 different times. So it's going to be raised to the 5th power. So we have 1/4 to the 5th power. Now, I like to put in my parentheses right here, just so that I remember that this is a 1/4 to the 5th power, and that I don't accidentally make a mistake and say that it was 1 to the 5th power over 4. And so I don't want to make that mistake, so I make sure I throw in my parentheses right here so that I can make sure I know that this 5 goes to the whole thing. Okay, now if we wanted to evaluate this, what we would do is we would take this 5 right here and we would move it in and put it on both of these numbers right here. So what we would end up having is 1 to the 5th power over 4 to the 5th power. 1 to the 5th power is just going to be 1 times by itself 5 times, which is going to give us 1. And then when we have 4 to the 5th power, we can do that on our calculator, and we can say 4 raised to the 5th power is going to be equal to 1024. Okay, so now as we look at this next problem over here, we can see that for our first number, our base is going to be a 0.3. And that happened 1, 2, 3, 4 times. So as we do that, that'll be 0.3 raised to the 4th power. And then as we see, our next base is going to be x, and that happened 1, 2 times, so it'll be times by x to the 2nd power. Okay, so as we go through this, we can start evaluating these expressions. That means we're going to be simplifying them. We're going to be evaluating those exponents. So as we do this, we can rewrite this with repeated multiplication. So that could be -2 times by -2 times by -2 times by -2. And we did it 4 times because it is to the 4th power. So -2 times -2 is going to be +4. -2 times by -2 is going to be +4. And +4 times +4 is going to give me 16 as my answer. Okay. Now the way that we would write this one over here with repeated multiplication is we would actually go negative and then 2 times by 2 times by 2 times by 2. And the reason that we do that is because we don't have the parentheses around this number. Okay? Whereas over here we did have the parentheses around that number, which means our base is this whole number. Over here, since we don't have that, our base is only this 2 right here. That negative number is going to wait outside the parentheses until after we're done evaluating our exponent. So again, we're going to get 2 times 2 is going to give us 4, 2 times 2 is going to give us 4, 4 times 4 is going to give us 16. And as we are evaluating this, we are going to pull down that negative, so our final answer on this is going to be -16. So the difference between our parentheses and no parentheses in this case is going to be the difference between +16 and -16. Okay, so as we evaluate some more expressions here, what we can see is we have this -3 inside parentheses raised to the power of 3, and we have this -3 outside of parentheses, no parentheses at all, raised to the power of 3. So again, as we write this as repeated multiplication, what we see is -3 times by -3 times by -3. And so 3 times by -3 times by -3 is going to give us a +9 times by -3 is going to give us a -27 for our answer. And in this case over here again, as we rewrite this, this is going to be a negative out front, and then 3 times 3 times 3. And as we see this, that means we're going to end up with a negative. 3 times 3 is 9 times by 3, so that's going to be a negative 27. And then we're ending up with a negative 27 as our final answer. So in this case, not having those parentheses wasn't that big of a deal, okay? But that's not always the case. The special cases we want to be on the watch for are when our exponents, these little numbers up here in the corner, are even, because in that case those parentheses are very important. Okay, so we're going to be working with order of operations now. So with our calculators that we have in class, we will be able to plug all of this into our calculator in order to solve this. So we can do 3 plus 2 times by 3 raised to the 4th power, and it gives me an answer of 165. Okay, but because we don't always plug in our answers 100% correctly, or sometimes our calculators might be off just a little bit, we want to make sure that we still understand the process of how to do this, and we can evaluate those one step at a time using our order of our operations, which is PEMDAS, where we are going to do parentheses, exponents, multiply and divide, add and subtract in that order. So as we look at this, we have 3 plus 2 times by 3 raised to the 4th power. So we're going to be evaluating our exponents first. So we're going to end up with 3 plus 2 times by, and then 3 to the 4th is actually going to give me 81. So now as I look at this, I'm going to then move into my multiplication stage. So 2 times by 81 is going to give me 162. So I end up with 3 plus 162, and when I add those together I get 165. So I can check that off. I got the same answer as I did up here, and so I know that I got the right answer. So again, as we look at the second problem with our calculators in class, we can go ahead and do 3 raised to the 3rd power minus 8 minus 8 raised to the 2nd power, and then divided by 2. So as we do that, I see that I get a negative 5 for my answer. But again, because we sometimes plug things in incorrectly, we still want to know how to work this problem out, and we're going to be following PEMDAS in order to do that. So as we look at this, the first thing that we're going to do is evaluate our exponents. So 3 to the 3rd power is going to give us 27, minus 8 to the 2nd power, which is 8 times 8, which gives us 64, divided by 2. And then as we do 64 divided by 2, we will be at 32, and then we have 27 minus 32. Say I have $27 and I need to pay someone $32. That means I still owe them $5. So my answer is going to be negative 5. So I can check that off. I can check that off. I can say, yep, I got the same answer as when I plugged it into my calculator. I should have the right answer. Okay, so as we're working with example number 3 here, using order of operations and evaluating each expression, we're going to go ahead and work these out using PEMDAS. So we need to remember PEMDAS, parentheses, exponents, multiply, divide, add, subtract. So with this, we're going to work inside our parentheses first, because that's the first thing that we're going to do. Inside our parentheses, we see our exponent, so we can go ahead and evaluate that. So we're going to do 1/2 times by 4 to the 3rd power. So 4 times 4 is going to be 16 times 4 is 64. So 64 minus 6 times by 3 squared, and 3 squared is 3 times 3, which gives us 9. So now that I'm done with that, I still am inside my parentheses, and inside my parentheses I can then multiply. So I do 1/2, and then 64 minus 6 times 4, which is 54. And then 64 minus 54 is going to give us 10, so we have 1/2 times by 10, and 1/2 of 10 is equal to 5, which means my final answer will be 5. Now as we look over here, we have the absolute value of 1/2 times by 7 plus 5 to the 3rd power. So again, working with PEMDAS, we're going to start inside of our parentheses. Inside our parentheses, we're going to see we have exponents. We're going to evaluate that first. So we have the absolute value of 1/2 times by 7 plus, and 5 to the third power is going to give me 125, and then a close parentheses and absolute value sign. Now as we do this next piece right here, we have 7 plus 125, and 7 plus 125 is going to give me 132. So I have the absolute value of 1/2 times by 132 inside my absolute value. So 1/2 of 132, so I take 132, I divide that by 2, and I end up with 66. So I end up with the absolute value of 66. Now, because absolute value makes everything positive, we can see a positive number is still going to be positive, so it's going to be equal to 66, and that's going to be my final answer. Okay, go ahead and try these both out on your own. Once you've tried them, go ahead and resume the video so that you can see if your answers match up with mine. So on this first one here, we have evaluate each expression. We have the absolute value of negative 1/2 raised to the third power divided by 1/4. And as we work this out, what we can see is we're going to have that exponent inside here. So we're going to do negative 1/2 to the third power. So that's negative 1/2 times by negative 1/2 times by negative 1/2. Okay, so when I do this, I'm going to do my multiplication across the top. So I should still have negative 1 times negative 1 is positive 1 times by negative 1 is going to give me negative 1. And then 2 times 2 is 4 times 2 is 8. So I should have negative 1/8 divided by 1/4. So as I do this, when I remember my process for division, I need to find the reciprocal of this second number. I'm going to then flip it upside down and multiply. So I have the absolute value of negative 1/8 times by 4 over 1, which is going to give me the absolute value of 4 over 8, and that's a negative. When I do that, I can simplify, and it's going to give me absolute value of negative 1/2. And when I see that, I can then say, oh, since it's in the absolute value, it's going to become positive, which means my answer is going to be 1/2. Now, as I'm finding the prime factorization of 532, I'm going to start with 532 up here, and I need to figure out what numbers are going to evenly go into 532. So the quick and easy way to do this is say, okay, I know this number is even, so I know one of those factors is going to be 2. And so I'm going to take 532 and I'm going to divide it by 2, and I'm going to end up with 266. Then I know 266 is also even, so I'm going to divide it by 2, and 266 divided by 2 is going to give me 133. Now as I look at this 133, what I can do is figure out what numbers are going to go into 133, and I believe 7 goes into that. So if we divide this, we can see 7 and 19 will multiply together, give me 133. Now 7 is a prime number because there's no numbers smaller than it that will be evenly divisible into 7. And 19 is also a prime number because there's no numbers smaller than it that are evenly divisible into 19. So what I have here as my prime factorization is going to be 2 times by 2 times by 7 times by 19. And I can rewrite this using exponents by saying 2 to the second power times by 7 times by 19. And I would be done. Okay, and we have our mini assessment here, so go ahead and try these problems on your own, put them in your notes, and I will check for them on Friday.